So now we'll be starting the editorial recording of Lead Code Weekly Contest 379. The first problem that we'll be solving is maximum area of longest diagonal rectangle. In this question, we are given with a two-dimensional array. Okay, it is called dimensions. All right, and every index of these dimensions contains of two elements. Okay, first is length of the rectangle and second is width of the rectangle, right? What we should be finding is we should find the area of the rectangle which has the longest diagonal. Okay, if there are multiple rectangles which has longest diagonal, then we should return the area of the rectangle having maximum area. Okay, that's the question. Looking at the constraints of the question, we are given that the number of rectangles which are given in input will be in the range of 1 to 100. Okay, there are total 100 rectangles can be given as an input, right? And each element inside this dimensions array will be having two elements. One is called length, the other is for width, right? It is also given that the length and the width have a range. They say that length and width are in the range of 1 to 100. With these constraints, we should find the area of the max. We need to find the maximum area of the rectangle with longest diagonal, right?
So yeah, let's see how we can solve this question. So we need to find the maximum area of the longest diagonal in this, right? So let's see what will be the diagonal for this diagonals for these test cases, right? Now the diagonal in this case will be, if this is one, this is the length and breadth. We know the formula for diagonal. Diagonal length will be basically under root of length square plus width square, right? So for this test case, the first diagonal will be under root of 9 square plus 3 square, which will be under root 81 plus 9, which is basically under root 90. Okay. And for the second dimensions, it will be under root 8 square plus 6 square, which will basically be 64 plus 36, which is under root 100. Okay. Now, if we compare these two values, we know that root 100 will obviously be bigger than root 90. So we can straight away say that from these this comparison, we can straight away say that this rectangle will have the longest diagonal. And we know the formula for area, right? Area will be basically 8 into 6, which is length into breadth, which will give us 48. Okay. So in this way, we can just make this comparison and we can say that the answer will be 48 in this case. So let's just take another test case into consideration.
The next test case is 3, 4.
3, 4.
4, 3.
4, 3. That's it?
Yes.
Okay. So in this test case, we both the dimensions are like just reverse. Length is width and width is length. So the length of both the diagonals will be the same. Basically 3 square plus 4 square, which will be equals to root of 9 plus 4, 16, which is 25. Okay. Now in this, we need to find the one which has the maximum area. And in this case, the area will be exactly the same. Basically 3 into 4 is equal to 4 into 3. So here the area will be equals to 12. Okay. But now what if there is a case where the diagonal length is same, but the area values are different. Okay. In that case, what we do is we return the one which has the maximum area, right? So what we can do in this question is we can run a loop and go through all the dimensions one by one. Okay. And then we'll do two things. Initially, we'll initialize some variable called, let's say, we initialize some variable longest diagonal. This is one variable, and we'll initialize another variable and call it our answer. Okay, we'll initialize both of them with 0 initially. Okay, now what we do is every time we come across a dimension, we try to find its diagonal, and if that diagonal value is bigger than this value, then we update it. Okay. If that diagonal value is bigger than this, then we update the longest diagonal value. Okay. But there is a possibility that, okay. One more thing, the moment we update the longest diagonal, we'll also update our answer. Okay. So if the diagonal is updated, we say answer equals to the maximum area by doing L into W, right? But what if the diagonal we obtain at a particular place is equal to this part? Okay. If it's equal to, we update the answer only in the case where the area is increasing. Okay. If the area is lesser, then we don't update the answer. Okay. So basically, that is just the two simple rules we need to follow while running a for loop. Also, one more thing we can do is we can solve this question without using the square root function as well. Okay. Now, in the question, we are not asked to return the longest diagonal, right? We are just asked to return the maximum area. So we don't even need to find the square root. We just need some parameter to compare diagonal lengths, right? So instead of finding the square root, we can just find this value, basically L square plus W square, and we can use that as the longest diagonal. Okay, so that's basically like a Manhattan distance. But yeah, we can use that parameter to compare diagonals, and based on that, we can find our answer. All right. So yeah, the time complexity for this question will be O of n. Okay, and space complexity will be O of 1. Okay. So yeah, this is how we solve the question.